Yeah, so Python Boolean data types. So you can open the notes on Python Boolean data types. Then we have our guide practices on this notebook here. So you can also copy that one and open it here. So this is actually what you're going to practice on Python Boolean data types. And also, like we've been doing it from day one, you have to be doing all the practices. So I would also advise you create a new notebook. So Google Colab, then you open a new notebook labeled Python Boolean class practices morning session. So, and then now we're ready to start. So make sure you have the notes from the e-learning portal. These are the notes you want to follow up together. This is actually what will guide us in our practice. We want to see how we can work with Python Booleans. Then these are class practice. So I want to take this one the shortest time possible, so that now we can start on Python conditional statements. So Python Booleans, Python Booleans, Python Booleans. Then class practice. Then we can actually give an hyphen. We say this is our morning session. Then because we're also going to have another class in the evening, so we'll call it Python Boolean class evening class. So make sure you have the three. These are the notes that you want to start so that we understand what are Python Booleans. These are the class guide on how we can now start working on Python Booleans. And then now finally, now we're going to do some class practices here. Okay, so let's proceed. So to start us off, we're going now to define what is a Boolean. We're going to start from there, unless there is a question. Yeah, unless there is a question. We had said we are still talking about data types in Python. And basically, data types refers to the various kinds of data you can deal with in your programming sessions. So we said we have several ones. We mentioned about numerical data types. So if you had any question with numerical data types, you can still follow this recording. And we had highlighted that we have the integers, the floats, and the complex. And we mentioned that we can actually do arithmetic operation to numerical data types. We've already talked about string data types, and we said that strings are basically text data types, where we can add operation like concatenation, we can do lowercase, uppercase, we can split, and so on and so forth. So that is basically the second data type we mentioned. So we mentioned numerical one. These were the strings. Then we went and did collection, where we talked about the list data types, where we said with the list data type, we are basically storing a collection of items inside square brackets. And we say that list data types are mutable. This means that we are able to add, remove, modify elements within a list. We did tuples. We said we store collection inside the round brackets, and they are immutable. We are on the same day, we also did sets. Yeah, we said that sets are an ordered collection that we use to store unique values, and they uses curly braces. So we also mentioned that with sets, we can do operations like union, we can perform intersection, we can check their difference, using some operations we have on sets. So if you want to follow through these tuples and sets, maybe there's something not still clear, you can actually open this recording. It's also on YouTube. And now yesterday we did Python dictionaries. We said that Python dictionaries store value in key value pair, comma separated. And we said that dictionaries actually is the foundational data structure for pandas. So I would really advise you that maybe if there's something not clear with Python dictionaries, you can still go through the recording session that we have. And now today we want to start on Python Boolean data types. So let's proceed together here. I hope you're there. I hope you're there. So it's already 9:28. I would think I give you the 2 minutes to ensure you have actually opened these notes here. Then from there, you have opened these operations that you want to do on Booleans. And then you have also opened your class practice now where you are ready to do some practice hands-on to do with Boolean data types. Yeah. Okay, so I think if everyone is ready, maybe if you're not, if we are fast, just let me on the chat session, and then we're going to it. And now let's proceed. So now Python Boolean data types are Booleans. We can actually say, so I don't know which link. Yes, the link, I forgot the link. Yes, let me share the link. Let me share the link on the chat session here. I hope now you have it. Then this one, you are going to create your own, because I want this one to be your own Google Colab, where you're doing your class practices on Boolean. Okay, so I want this one to be your own new notebook that you're going to save on your Google Drive here. So make sure you open a new notebook. Then you create a class practice notebook where you're going to practice on the same. So now I think everything is okay. Now we can start from here. So we can actually say that Booleans are built-in data types in Python that it's actually used to represent one of two values. So it can only be of two instances. Binary, I think in other words, it's called a binary data type, where it only represents two values. And these two values, it's basically true or false. And if someone you have already done some binary systems, normally true is denoted as 1, false is denoted as 0. So this is basically, we are actually learning ones and 0, okay? They are very, very essential for performing logical operation and decision making. So remember, so far so good, we've already done arithmetical operation, and now we want to talk about logical operation, so that now we're able to have something called the arithmetic logic unit in our programming. So now to start performing logical operations, then you're going to see that Python Booleans are very, very important. And that's why I had planned we just do them today. So some of the characteristics of Python Booleans is that they have binary values. So if something is binary, then it can only hold two possible values, can only be of two possible values. That is, it's either true or it's false, okay? Another aspect is in Python Booleans is that they are very case sensitive. So this means that the values must be written with uppercase letter, okay? If you want to write Boolean true, then make sure you start with uppercase true. And then similar false, you start with uppercase false, okay? So the third one, which is also very important, allow me to mute some mics. Yes, sorry for that one. So I was talking about Booleans. I've said they are binary, so they can only be of two possible options. It's either true or false, 0 or 1, okay? It is case sensitive. This means that in Python, you'll have to write capital T, true, and capital F, false. You don't write them in lowercase because they are sensitive to their uppercase initials. The third one, very important, is that they have some logical representation. This means that for you to derive Boolean data types, they can be actually derived as a result of comparing what you call comparison operations and logical operations. So for you to get a Boolean, you can either compare or perform a logical operation. Let's say, for example, I want to see whether 2 is greater than 3. Then you'll get a Boolean, maybe true or false. So initially, if you go to the computer internal system, Boolean is mainly treated as 1. I think I've mentioned this one. And false is actually treated as 0. Okay, so you can actually work with them in embedded system whereby you're treating true as 1, false as 0. And you actually realize that machine language is mainly written in form of zeros and 1. Okay, so those are the main characteristics of a Boolean data type. Now, how do you identify Boolean in your program? So you can actually say that Booleans can be assigned directly. So you can just create a variable and assign true. Like I can say here, variable is equals to true. So you can assign them directly. And you can see that it is denoted a certain color. Or they can be as a result of expression. A good example is maybe I want to see whether 2 is greater than 3. Okay, so if you run this one, you get an expression that this is either true or this is false. So that is actually where you can actually identify Boolean data types in your programs. So to proceed, I think this one is taking time to connect. I think it has connected, or that is false. So you can actually assign them directly, or you can get them as a result of either comparison operation or logical operation that you're going to do later. Okay. So in some instances, any value that is non-zero or non-empty collection or strings are evaluated as true. So when something exists, we can evaluate it as true. Then when we have 0 or something that is empty or an empty string or a none, then most of the time they are evaluated as false. Okay, you're going to see that one later. And now to see where to use Boolean operation, you can see there are so many operations where you can use Boolean. The first one is Booleans will guide us on decision making in conditional statement. So this is actually what you're going to do in our next topic. So for us to understand decision making, a process in programming, then we'll have to understand Boolean data type. So because with Boolean, we can determine whether a block of code should execute or not, okay? So Boolean will also guide us in our logical comparison. So Boolean simply simplified decision-making by evaluating conditions, such as comparing values or checking membership in a collection. We're going to see this one later. We can also use Boolean to define default tag. So it is used for toggling features and setting default option in application. I can even give you a good example. We can have an application like this one. Let me just show you. I think I've already seen it. So right now we actually say that light theme is true. So now we're able to see the light theme as true. If I want to make it dark theme, then I turn the dark theme to true now. I hope you can see. So now the light theme is false, the dark theme is true. So if you want to have such kind of default settings that we have, then we normally work with Booleans like this one. So this kind of settings are basically built using Boolean data types and so many other ones. Okay, so Booleans are also very efficient for conditional testing. So Booleans allow concise checks without explicitly comparing values, making code cleaner and easier to maintain. So these are actually some of the use cases of Boolean data types, and we're going to see them in our class practices. So in summary, we can actually say that Booleans are fundamental in programming. You cannot do any programming without talking about Booleans, because they serve as the foundation for logical operations and conditional statements. Okay. So Python evaluates condition in either truthy or falsy condition manner, even when not explicitly Boolean. We're going to see that one later. And we're going to see that Python Booleans are widely used in control structures, logical comparisons, and data processing tasks. So these are very, very important data types that you're learning today. So to now avoid more of the theories, let's now do some class practices so that now we clearly understand these Boolean data types. So I have opened my notebook here. So Python for data science, Python Booleans. So you want to start from here. Make sure you also have your class practice notebook right here. So I want to remove this one. This was basically, by the way. So to start, I think we normally start by definition. We can basically say that a Boolean data type represents one of two values. So it's binary. It's either true or false. So the use of this data type will be clear once we start using them in comparison operation. They might not be clear right now, but now when you want to make some comparison, I think they'll now make much more sense. So to keep in mind is that the first letter, true, must be capital, and the first letter F should also be capital, unlike other programming languages like JavaScript. So if you're learning a programming language like JavaScript, then their Boolean data types are normally in lowercase. So I think I want you to try out these ones and then confirm that now we are actually working with Boolean. So I can actually say Python Boolean data types. So you can actually paste them right here. So if you run this one, these are basically the Boolean data types. So now to clearly understand why we need Booleans, then we might now want to do Python comparison operation. So let's go there. Go there. So comparison operation. So I can actually say that in programming, we can compare values. We compare values by using comparison operators, okay? So we normally check if a value is greater or less or equal to or other value. So the following table shows some of the Python comparison operators that we have in Boolean data types. So they're here. So you can either compare whether one value is greater than is equal to the other value. So we normally work with two equal signs. Because if you work with one equal sign, then you are actually assigning variable to a data type, okay? So if you use two equal signs, then you are comparing whether one value is equal to another value. So if you want to see whether a value is not equal to another one, then you can now say exclamation equal to. So this one means that not equal to another value. You can also check whether one value is greater than another one, another value is less than another one. This is actually evaluated as greater or equal to. So greater or equal to, and this one is evaluated as less or equal to. So these are actually the example. I want you to copy this code and now try them out here. And then you can even do more operations with that one. So I want you to copy these codes and then you paste them right here. That one. And now if someone, let me first say that if I want to print, so I want to see whether 3 is greater than 2, then basically I can run and then I get a Boolean that that operation was true. So it is true to say that 3 is greater than 2. So this is actually a Boolean. Another occasion is when I want to see whether 3 is greater or equal to 2, because you can actually say that this is because 3 is greater than 2. Now this one is false because 3 is greater than 2, so this operation here is false, and so on and so forth. So basically, this is how we now perform comparison operation. And I hope you're seeing that we can perform comparison operation in numbers, can do them in numbers, and we can also do them in strings. I want to see whether, let me print here a delimiter. So I want to print here just a small space. So now here, I want to see whether the length of the text mango, can you see? These are how many characters? 1, 2, 3, 4, 5, is equal to the length of the text avocado. So avocado has 1, 2, 3, 4, 5, 6, 7. Because this one has 5 characters and this one has 7 characters, their lengths are not equal to each other. So this means that that is false. So it is false to say that the length of mango is equal to the length of avocado. So now, if you now compare in reverse, where we are saying that the length of mango is not, this one means that it is not equal to the length of avocado. Now that one is true. So it is true to say that mango has 5 characters, avocado has 7 characters, so their length are not equal to each other. So that one evaluates to true. Alternatively, we can now say that the length of mango, which has 5 characters, is less than the length of avocado, which has 7 characters. So that is true. I hope you're seeing them here. Similarly, the length of milk, 4 characters. The length of meat, 4 characters. How many? So if you want to, because they have the same length, this is actually 4 characters. This is 4 characters. So if you say we want to check whether they are not equal to each other, then that one will be false. That one will be false because they are actually equal to each other. So if I compare whether the length of milk is equal to the length of meat, then that is true, and so on and so forth. So basically, in summary, we are trying to say that for you to evaluate Boolean operators, the first thing you have to do is to perform comparison operation. So let's define them here. So you can actually say that they compare, okay, sorry, not compare, they check a relationship between one variable stock value to another one. Yeah, so if you are doing a comparison operation, then you are basically checking a relationship between one variable or one value to another one, okay? This is very important for me to say. Comparison operation, let me just say, they normally form a condition. They normally form a conditional statement. Conditional statement. So they basically form a conditional statement which evaluates as true or false. So if you're doing a comparison operation, basically you are checking the relationship between one value or one variable to another one, okay? And the condition might evaluate as true or as false, okay? For example, I have this value 3, I have this value 2. So I want to check their relationship. I want to check whether this value is greater than this other value. So it's either true or false. And this is what we call Booleans. These are actually what we call Booleans. So if you actually create a condition, as you're going to see in our next topic, a condition statement evaluates as either true or false. Okay? It either evaluates whether the condition is either true or the condition is false. I hope you're now trying them out. In case you get an issue, you can always ask. Also, let's try something here. Let's try something here. Let's try something here. Let's even talk about how our computer system works. So your computer system or your laptop are stored a password. Maybe your password is 25. Okay, or let me just say your password is 1, 2, 3, 4. Your computer system has stored your password as 1, 2, 3, 4. Okay. And now there is the user password. So the user password is what the user is requested for. So remember, we can actually request for this user. Okay. So I want to request it as a number because we have actually stored an input, which is a number. So this is a number, this is an integer. So we request for an integer, and then we have an input here. We have an input here. Sorry. We have an input here. Then we put function, then we say enter password. So remember your password is 1, 2, 3, 4. Now the user will be requested to verify whether he actually have an idea of what your password is. So now to ensure that the stored password and the user password are okay, we can actually make a condition. So we can actually create a condition to check whether the stored password and the user password are the same. So to do that one, for now we can basically print whether, I want to print whether the password that I've stored in my computer system and the password that the user is being requested for is the same. So if that is the case, then we can basically say that the user is actually given access to the system. So I want to give a small statement here, like that one, yeah. So now let me run this one, here. So now the computer has stored your password. So if you provide the same password, 1, 2, 3, 4, then that one evaluates to true. So if you see true, this one means that the stored password and the user password are the same. I wish to share this one with you so that you can also be trying them as we are now explaining them right here. I'll share that piece of code, then you can test them out. So basically, we are now saying that the stored password is 1, 2, 3, 4. And it is actually an integer. Remember, it is an integer. So if I were to request for the user password, I will have to request for an integer. Then I have the input to give me that password. So now if you run this piece of code again, remember the stored password is 1, 2, 3, 4. So if you give a password like 2, 3, 4, 5, then the condition will evaluate to false. So it is false to say that 2, 3, 4, 5, which is the user password, is not similar to the stored password, which is 1, 2, 3, 4. And that's what actually how we build authentication system in applications. So that is actually one scenario. Let me just try one more. The stored password is 1, 2, 3, 4. So if I want to get true, I will only have to provide a password that is similar to the stored password here. So I can, if I now say 1, 2, 3, 4, then you press enter. Remember, after you've actually given the input, you need to press enter so that now we can perform the operation of comparing the stored password with the user password. If the stored password is 1, 2, 3, and 4, and the user password you've entered is 1, 2, 3, and 4, then the condition must evaluate to true. So let me press enter here and press enter here. Allow the condition evaluates to true. Okay, so that is one location. I hope you've tried. In case you get a challenge, let me know on the chat. Also, we can also compare something. Comparing something gives either true or false. So if you compare something, it either gives you true or false. So if I compare true and true, I will always get, let me just see this one here. Let's see this one here. Let's paste it here. On a new code cell here. Then you can paste it here. So if you now compare this one, if you compare true and true, we always get true. That is 1. If you compare with 1, we always get true. If you compare true and false, we always get false. If you compare whether false is equals to false, then we always get true. Okay? So I want to see whether true is similar to true, then I always get true. True is similar to false, then I get false. Then false is equals to false. Now we always get false. So this one clearly shows that comparing values gives either true or false. I hope now that is okay. So we've actually mentioned now the comparison operations in Booleans. So if you don't have a question, you can now try out the next part, which is now. So in addition to above comparison operator, Python uses more operation like is. So is returns true if both variables are of the same. So we maybe want to see whether x is y, okay? So the opposite of is that is not. So it returns true if both variables are not the same. I think we've already done the in and the not in membership where we said that in returns true if the queried or the requested list contained an item in X. Alternatively, not in returns true if the queried list doesn't contain that one. So to demonstrate that one, I can actually use this one here. So I can actually say there is and not is operations. So if you try this one out, I want to see whether 1 is the same as 1. So this is true because the data values are the same. So it is normally used to check. So I actually say they are used to test similarity of two objects. Similarity of two objects here. Okay. So for example, I want to see whether 1 is the same as 1. So that is true. 1 is the same as 1. So if I now say I want to see whether 1 is not 2, then that is true because 1 is a different object and 2 is a different object. So they are not the same. So it's not, it's actually true. I also want to see whether character A is present in the string here. I want to see whether this string contains character A, and that is true. So it is true to say that A, it is present in this character here. And now B, I want to see whether B is present in the string here. And you can now see that B is not present because this is actually uppercase B, and the one that is present here is actually lowercase b. So you can literally say that B in this character, that is false. Okay. So I want to see whether the value coding is present in the text coding for all. And you can actually see that the value coding is here. So that is also true here. Yeah, then I want to see whether A is present in text and, then I can actually say that N is actually part of and, then that is true. So what this one actually tries to show is that yeah, so these are some of the syntax warning. Where they're trying to show us that instead of working with is, we can actually work with equal. This is actually the same, but actually we're getting the same output by actually checking the is operators and the in. So I think we have already checked the in and the not in operations. So they also return Booleans in such a way that they are basically used. They are basically used to test membership. They're used to test membership of certain values. So you want to test whether a value is a member of another one. Like, for example, I want to see whether A is part of the string. So you actually use them to test membership. So I will post this one for you to try them out and let me know in case you're getting a challenge or maybe something that is not clear. So also good. Now we've not had a question, so I think we are okay. Now moving further, let's now talk about logical operators. And now this is actually where I want us to take our time. Logical operators. Logical operators. So Python logical operators. So what I can actually say is that they are used to check a relationship. Take a relationship between, they are used to check a relationship between one condition and another condition. So now let's check the major difference between a comparison operator and a logical operator. So as you can see here, is that a comparison operator was actually checking a relationship between one variable or one value to another one. So you can have this value, you're checking its relationship with another value, and they normally form a condition. Okay. Now, on the other hand, logical operators, they are mainly used to check a relationship between one condition and another condition here. So let's see what our notes are saying. So unlike other programming languages, Python will often use and, or not logical operator. So this is actually something important to note. So Python uses and. So remember, and we had said it is what we call the intersection. I think we did them in sets. Python uses and, or that we said we called it union, and not that we called it the difference. Remember that one in sets. So this is actually what we use in Python to actually check relationship between one condition and another condition. So you can either say and, or not. So now to explain this one, so that now we can explain this one here, we can explain this diagram here and do some practices here. And let me start with number one, or A, and you can actually say that it evaluates to true if both conditions are true, are also true. So anytime you're interacting with and a logical operator, it will always evaluate to true if both of the conditions that you are checking are also evaluating to true. Okay, we're going to see that one in a short while. B, or logical operator, we can say that now this one, it evaluates to true if, now the keyword is at least one of the conditions evaluates to true. Okay, at least one of them is true. At least one of the condition is evaluating to true. Then the OR operation becomes true. And then finally, the last one, C, which is actually the not. This one basically it returns. So this one returns the opposite. That is normally called the reverse. The reverse of a condition. It normally returns the opposite or the reverse of a condition. So if a condition was made to true, not will actually return the reverse for that one, and it returns false. So now let's clearly see them in a flowchart diagram, in this diagram here. So if someone talks about and, so this is what we call the and. So this is what we call the logical operator, and. So you have this condition here. So there's a condition to check whether 5 is less than 2. And there's also another condition to check whether 5 is greater than 3. So because we have these two conditions here, I hope you can see this is one condition, this is another condition. So if you want to compare, if you want to check the relationship between one condition and another condition, now that is the point where we use logical operators. So this condition will return false, and this condition will return true. So this one will become false because we've said that if you work with and, this has to be true, and this has to be true. So for this one to be true. Let's even see the OR operation. So we say that the OR operation is when at least one of the condition is true. So like you can see here, 5 is less than 2, that is false. But now at least if you compare this one, 5 greater than 3, then this is true, then this one becomes true. It is true because at least one of the condition is true. And then finally, not returns the opposite of a condition. So if this condition that we are checking is whether 5 is less than 2, it will return false. Now, if you add the not, which is actually represented with the exclamation, then we are going to get true. And this is actually how they work. So let's try out this one, and now we can go to Python, conditional statements. And now, unless there is a question, so let's try out here, like that one. So these are logical operator, and let me say, let's go to see that one here. So I want to print here, string, and I'll say this is and. It's basically and. Now I can copy this one. I would paste it here. Then I would say this is or, so that you can see that one. And then finally, also here, I would paste here and say this is not. And now we can actually say that if I run this code, please, I want this one to be very clear. In case it's not clear, you can always ask. So if you start with and, we want to see whether if I compare 3 is greater than 2 and 4 is greater than 2, because both statements, or let me say both conditions, and even add stroke conditions, because both of these two conditions are true, this one will become true. It will only be true if this condition is true and this other condition is true. That is only the point when you get this evaluation as true. Okay, let's see the other occasion. The first condition is true, the other condition is false. So this one becomes false because the second statement is actually evaluating to false. Okay, so for you to have and as true, then both of these two conditions, this condition here and this condition here, they have to evaluate as true. Okay, if one of them is evaluating false, then the whole expression becomes false. And then finally, now we have this one. 3 is less than 2. This is false. This is also false. Because both of these statements are false, the whole condition evaluates to false. So this is actually how AND works. So always remember, AND operation, it will only be true when both of the condition, the first condition and the second conditions, are evaluating to true. Now, on the other hand, if you want to check the not, you're actually seeing that not or, it has to be at least one of the conditions has to be true. Okay, like for example, here, we are seeing that 3 is greater than 2, 4 is greater than 3. This is true because both of them are true. Okay. Then also here, we're now checking whether 3 is greater than 2. This is true. 4 less than 3, this is false. Because at least this one is true, then the whole condition evaluates to true. Okay, so it has to be at least one. Because one of the condition is true, then the whole expression is evaluated as true. And then finally, if I check here, this is false, this is false. So it will only be false if both of the statements are false. And then basically the note, as you can see here, is that 3 greater than 2 should have been true. So because 3 greater than 2, this should have been true. Then not gives true because gives false. Not true gives false. So not will actually return the reverse of this one. If this one was meant to be true, then it will return false. Okay. So if you say something is not true, then something is false. If you say something is not false, then that is true. Okay, if you say something is not true, then that is true. Because this one evaluates to false. And let's see that one. This one evaluates to false. Then the reverse of that false is true. Okay. Then not false is a scenario whereby this one evaluates to true, so the reverse for that one is false. So not false, that one is actually false. And basically, these are the logical operators we have. So just to summarize them, we are actually saying that a comparison operator, it is used to compare one value with another one, and they always return a Boolean, either true or false. On the other hand, a logical operator, it is used to compare between one condition and another condition. So you can compare them as either true, as and, or not. And we have actually said that and will only be true when both of the conditions are true, or will evaluates to true when at least one of the condition evaluates to true. And then finally, not will actually return the reverse of a condition. So I wish to share this one with you. And now, if you have any question, you can always ask up to this point. So these are some very useful notes you can use. Just paste them on your class practices. Now I can also share this one here. So basically now that one marks the end of our data types, where we started with numerical data types, we did string data types, we did sequence data type, that was list, tuples, we've talked about sets, dictionaries, and now today we have completed our data type sections by talking about Booleans. Okay, we talked about Booleans here. So in case you have a question with Boolean, anyone with a question with Boolean? Any question with Boolean? So I've shared all the materials on the chat, and also you're going to find them on this notebook that I will share later. So I think there's one. I don't know what Grace, you've actually typed S. I don't know what it means. Was it a question? Was it a question? Yes, so what's the question? What's the question? If it's a question, then what's the question? What's the question? Okay, so if no questions, then this one now will take us to the next module where we're going to talk about Python conditional statement. Basically, we're now talking about, oh, you wanted me to repeat or not? Yeah, that's okay. I can do that one. So I was saying that we have and when both of them are true, and will evaluate to true, or it's when at least one of these conditions is evaluating to true, at least one, okay? Now the note, it is a situation where we're actually returning the reverse. So let me just show you that one here, and maybe I can do one more here, and do one more here. So if I have this condition, like I want to see whether 100 is greater than 50. So obviously this should be false. Let me show you that one. This should be false here. Yes, this is true. Yeah, 100 is greater than 50. That is true. Can you see that one here? So if I want to return the reverse, the opposite of this condition is evaluating to true. So if I add not here, then if this condition is evaluating to true, then it might now evaluate to false. So let's run this one again. And now we are confirming that that is false. So basically, not returns the reverse of a condition. So if a condition was meant to be true, not return false, and vice versa. Okay. So a good example was the one they were showing here. 3 greater than 2, that was true. So if you say not, then it returns false. Okay. Yeah. I hope I've answered that one for you. And now we can now proceed to the next module where we want to introduce. Yes, you're welcome. So we want to introduce Python conditional statements. I hope you are ready. You can mark this one as complete. And now we introduce the next module. So far, so good. We have tackled variables and data types. So now we want to go to other components, which we'll actually do them in a very short time, actually for this week. So now let's start from here. In case there's no question, now we can introduce Python conditional statements. Okay, so let's start. Before we start, I want us to do our our setups. I would share this one with you. Yes, you want it, and share this one with you. Yeah, I've shared that one. So I want to close it here. I also want to close this one here. So the first thing I want to do is I want to open these materials here, the material that I have here for conditional statements. I'll paste it here, that one. And then I also want to open our practice notebook. So Google Colab. So here we are actually practicing now on Python conditional statements. So just create a new notebook, and then we can call this one Python conditional statements. This is actually our morning session. Sorry, Python conditional statement class practice. That one. So Python conditional statement class practices for the morning session. So now I think we are ready. So we have the notes. As usual, these are the notes you want to follow. This is actually what will guide us on how to create conditional statements. As you can see, there's not that much. Most of them are some practice exercises that you'll do after this session. And then now this is what we want to do, our practices. So let's start here. Let's start here together. And now we are saying by definition, conditional statement in Python allows the execution of specific blocks of code based on whether a condition evaluates to true or false. So now remember, now we are now actually transition from Boolean to conditional statement. So basically you want to execute some specific blocks of code based on whether a condition is evaluating to true or the condition evaluates to false. So these are actually the foundation of decision-making in programming. So in some point, you want your program to make a decision. A good example is, can I give access to this user? Can I deny access to this user? Can you withdraw some cash from your account? Maybe you can actually check some condition like your balance and so on and so forth. So key characteristics of conditional statement is that they are actually the decision-making tools. So conditional statement enable different action depending on different conditions, okay? They can now control the flow of a program because they guide the execution path of the program based on logical conditions. And actually, we can also say that Python conditional statements are based on the Boolean logic, okay? So you can actually say here that conditions use Boolean expression that evaluates to either true or false, okay? So in Python, we have almost 5 types of conditions. We have the if condition, we're going to see that one. We have the if-else condition, we're going to see that one in a short while. We have the else-if conditions, the nested condition, and the ternary conditions that you want to do right now, okay? So now where do we use these conditional statements? We are going to use them in our decision-making when we want to execute specific actions based on user input, system states, or data values, okay? We are also going to use decision-making to handle some errors. Remember, we've been talking about exception handling. So we're going to handle exception or invalid input using conditional logic. So we are going to do them in exception handling. And also we are going to use a conditional statement in multi-condition check, whereby we evaluate complex scenarios involving multiple conditions using the Python else if statements. And actually, finally, we can also say that Python conditional statements are the efficient flow control. They optimize the program's behavior by skipping unnecessary computation when the conditions are not met. Okay. So in summary, we can actually say that for you to be very good with Python conditional statement, then indentation is crucial. So indentation will define the scope or the boundary of the conditional blocks. So conditions should be clear and concise to enhance code readability. So anytime you're writing a condition, make sure it is actually clear. And then you're going to also notice that Python supports chaining of multiple conditions using and, or not, especially if you're dealing with more complex logical checks. We've mentioned this one. And then at some point, you're going to see that Python uses ternary expression for compacting conditional assignment. So let's try to demonstrate what you're talking about here in these notes that we have here. Then in case you have a question, please don't hesitate to ask. Okay, so to start us here, go here. This is very important. We've been told that by default, statements in Python script are executed sequentially from top to bottom, okay? If the processing requires logic, then the sequential flow can be altered in two ways. We can alter how the program executes by using either conditional execution, that we're calling it decision-making, or repetitive execution that later we'll be calling them loops, okay? So this is what the code means. By default, the program execution, by default, the program execution executes sequentially. For example, I can have a variable called number. And this variable, I want to make sure it's an integer. And then we are going to input that integer to our application. So we're going to say, enter an integer, digit. So give me an integer digit. Digit. It's that one. So enter an integer digit. From there, we can now say print the integer is positive. So let's start from here. And we can also say print the integer is negative. So this is what we basically called the sequential flow of programs. So this is what we call the sequential how do you write sequential flow of programs? So I think it should have been here. Sequential, yeah, sequential. So this is basically where codes are executed line by line without skipping any line of code. This is what happens by default. So I wanted to show you that by default, if you're creating a program, then code will execute line by line without skipping any program, any line of code. So I would wish you can try out that one. You can also try out that one. So now we're seeing that by default in Python, codes execute line by line. For example, here, I've been told to enter any digits. I enter a digit like 5. Now we are going to notice that I've executed all the codes. I've executed saying that the integer I've entered is positive, the integer I've entered is negative. So you see that something is wrong here. We'll need to add a decision-making process to tell us that if you entered a positive integer, then there is no need to execute this line of code. Or if you entered a negative integer, there is no need to execute this line of code. And this is what we call control flow. We want to control the flow of program execution based on the condition we have, okay? Based on the conditions we have. So that by default, this is what happens. The program executes line by line. The first one execute, the next one execute, the third one execute. So I can actually add that in this scenario, we can actually say that there is no indentation of programs. So in the sequential execution, you don't actually add an indentation because it raises an error. Okay, so if I indent my program here, for example, if I had an indentation here, I'll show you this one, maybe I do this one here. If I run this code, I will get an error being told that this is an expected indentation. So if you're doing sequential flow of program, then we don't add any indentation. I hope that one now makes sense, okay? If I enter a number like -7, I press enter, I'm still being told that -7 is positive, -7 is negative, okay? Which is wrong actually to say. Now let's proceed here. So in Python and other programming languages, we have 3 types of conditional statements. So we have the if, the else, and the else if statement that we can actually use to control the flow of a program. So we want to start with the if condition. So let's go here to start with the if conditions. The if conditions. Right. So now we're saying that in Python and other programming languages that we have out there, there is a keyword called if that is used to check if a condition is true and to evaluate the block of code. So then we are being told here that, remember, anytime you are now using if condition, there is an indentation after the colon. So this is actually what happens. This was the sequential flow of the program, this one here. Then we meet a condition. So a condition is a situation whereby we are checking the relationship between one variable and another one. So we have actually said that if you have a condition will always evaluate either true or false. We said that one in Boolean operation. So if this condition evaluates to true, then some statements will be executed. And you see this one here. And then our program ends. Alternatively, if the condition evaluates false, nothing happened, the program just stops. So this is actually how it's actually done, okay? It's actually how it's done. So you can actually say that if, this is a syntax, if, then you pass the condition, okay? we pass the condition. If this condition is true, this code that we have indented here, that we call the condition body, will be evaluated, will be executed. Otherwise, if this condition is not true, then this one will be skipped. Okay, let me show you that one here with this example that we have here. So I want to proceed with this one here. So you can actually say that if the condition evaluates to true, we've said that one, say that one in Boolean, the indented block of code is executed. Otherwise, if the condition is false, the program ends. Okay, so let me show you that one here. So I want to use the same scenario. I've told you to enter a number, so please enter a number. Give me a number here. Give me a number. Now we are now saying that let's have the condition that if the number that you're entering is greater than 0. Yeah, I think I should remove this one. It should not be here. So this is what happens. If I've actually told you to give me a number, and you say that if that number is greater than 0, then you can now say that the number is positive. So if you give me a negative number, nothing would happen, okay? Nothing would happen. So this is what you call an if statement. And this is actually how it's created. We have the if, we pass the condition here. So the condition is where we're checking a relationship between this variable and this value. And it's either true or false. So if it's true, according to the flowchart diagram here, if it's true, we are going to execute some statements. So the statement I want to execute is what you're seeing here. Otherwise, if that condition is false, I will not execute anything. This is what we call the if statement. So for you to do the indentation, we normally pass the semicolon here. So this semicolon that I've entered here, the full colon that I've entered here is to end the conditional statement. So you actually say if condition, you pass the full colon, then you put your statement here. So let's try to run this code again. Let's run this code again. Now this one is better. This was executing everything. Now this one is even better. Now we can say that if I enter a number like 8, I'm told the integer is positive. That's okay. Let me try another scenario. If I enter a number like -6, I don't see anything. I don't see any execution because this condition is evaluating to false. So if the condition evaluates to false, we don't execute anything. So if I say -5, press enter. So -5 is not greater than 0. So this one is false. So then this code will be skipped. Okay. So I want you to try that one. I want to try this one. You press enter here, and then nothing happens. So this is what we call the if condition. I'm sharing that one on the chat. In case it's not clear, please feel free to ask the question. So this is what we call the if statement. According to the flowchart, we are also seeing that the same. We have a condition. If the condition evaluates to true, some statements will be executed here, then the code will end. Alternatively, if the condition evaluates to false, the code will just end without executing any statement. This is actually the syntax, which actually say if we pass our condition, we end the condition with a full colon, and then we put some statements here if this condition is actually true. Okay, so this was a good example. I had a is equals to 3. If a is greater than 0, then it's positive. So then you're being told there that, as you can see in the above example, 3 is greater than 0. Okay, so the condition was actually true and the block of code was executed here. However, if the condition is false, we do not see any result. In order to see the result of the false condition, then we should have actually added another block that we call the else condition that we want to do in the next part. Now let's talk about the if else condition. So this is okay, no question. So this is number 1, the if conditions. We can now go to number 2. Number 2 here, now we are talking about the if else conditions. The if else conditions, okay? The if else condition. So what we are actually saying is that for if else condition, you're actually saying that if the condition evaluates to true, I know this should not be the case. If the program evaluates to true, the if block is executed. Otherwise, the else block is executed. Let's see even the flowchart diagram. So in the flowchart diagram here, that is what we are being shown. We have the program starting here. So reduce it a bit so that you can see. So our program starts here. I hope you can see our program starts here. Then if this, we have a condition that sometimes is called an expression. If this condition returns true, then we are going to execute the codes that we have on the if branch, and then the program stops. Otherwise, if this expression evaluates to false, then we are going to execute the else branch, and then our program will stop. So let's see that syntax. See that syntax here. Let's see that syntax here. So the syntax is that, I hope you're seeing that one. Let me increase the size a bit so that you can see. So the syntax is, if this is a condition and this condition evaluates to true, then we are going to execute what we have on the if block. And you can see that it is normally indented. We'll have to indent it to show that this is the boundary of the if block. This is the boundary that will execute when this if condition is true. Then else, this is the part where now when we have this condition returning false, okay? This is when this condition returns false. So we have the if block and we have the else block. Let's modify our code here. So we were already here. Just copy this one and put here. So now we were saying that we have a number that is an integer. If that number is greater than 0, full colon, we are ending that condition. This is a condition. It's either true or false. Then if it's true, we are going to execute that the integer is positive. Now we go to else. Please check where we put else. It has to be in the same indentation with the if. And this is where we put else. Then we put full colon again, and then we print that the integer now is negative. So we have, this is the if block. When the if is positive, is true, we execute this block of code. When this is negative, this is actually false, we execute the else block. So I want you to try this one out. I'm also trying it on my end here. So that's this one like that one. So now let me try this one here. Now you're saying that if I run this piece of code, enter any number. So if I enter a number like 7, you can now say that now we're able to make a decision that 7 is actually a positive integer. Let me try another one. I run it again. How about I put -4? Then I'm being told that -4 is negative because it's negative because it's returning false here. -4 is not greater than 0. So now we're able to now start making decisions in our program based on whether conditions are true or whether they are false. Let me execute this one again. What if I enter a number like 100? So if I run this one, just press enter. Then I'm being told the 100 is positive because 100 is greater than 0. So this condition will evaluate to true. So we are going to execute the if block. Otherwise, if I have another occasion where I put a number that is negative, let's say -300, this condition will evaluate to false. So the else block is what we are going to execute, and we're being told that -300 is negative. So basically, this is the basis of how programs are able to make decisions. Any question up to there so far? So now we can move to the next part, the third one. And move to the third one. If we don't have any questions, we can now move to the third one. So in the third one here, so we're being told here that the condition above. So make sure you provide an input. Make sure you provide an input. If you run this one, you'll have to give it an input first. You'll have to give it an input here. You'll have to give it a number, let's 45, then you press enter. You press enter, you press enter. Then now that is when it's actually providing a number. So if that is not the case, then you can erase this one and just enter your number here. You can actually enter your 45 here. If that is not the case, you can still do the same here. And now you still get your output. So you can either request the number from the user or just put it here directly. You can actually say that 45 integer is positive. If I say -45, that is negative. So that is another alternative you can try out. So I hope now you're okay up to there. Yeah, so we can also say is or is not. We can also say is or is not, but I think we can use it in characters. But if you want to use is, just change there to is. Okay. Then now the expression should say that the number is 0. Then you want to check whether, we said is when you want to check whether there is similarity between this number and this number here. Okay. I think you're going to do it at some point later. Yeah, so frankly, you're asking a very good question. Can we create a program that checks whether we only have passwords that are letter only? Yes, we can check that one. I think there is a function called is alpha numeric. Is alpha. So like, for example, here, let me try it on a new. You can even try out that one before doing the next one. So let's try here. So that one we can use a function called is alpha. So that one. So what you'll have to do first is to request the user for the password. The password, remember, it's a string. It's not an integer. It is a string. So you'll have to say STR. And then we have the input for that password. Then you tell the user, enter the password as an input. And you're ensuring that the password you're entering, it's actually a string. Okay. So now to check whether the password is having letters only, then we can actually say that if password dot, there's a function called is alpha. I think it's called that one, is alpha. This one here. So this one is either true or false. It is either true or false, whether the password is alphabet, is letters only, or with numbers. So now we can say here, so we can basically print here, we can print, can say the password is made of alphabets. I don't want to do a lot. So we can now go to else. Now we can say the password is made of alphabets and numbers. Okay. So now this is actually how you can check whether the password is made of password only. So if I write a password like admin, then I'm being told it's made of only alphabets. So if I try another one like admin 1 2 3 4, admin 1 2 3 4, then that one is actually showing that the admin 1 2 3 4 is made of alphabets and characters. So you can actually call some string functions like is alpha. Okay. I hope I've answered that one for you. So any other question, in case you have any? Okay, so if there is another question, now we can go to the third type of a condition. So far we've checked number one, the if condition. We have checked the if-else condition. Now we are talking about the else-if condition. So we are now talking about Python if, else, if, else condition. So here, they are mainly used. So they are mainly used. They are mainly used to check multiple conditions. Multiple conditions. They are mainly used to check multiple conditions, and we can also say that it evaluates to if one of the multiple conditions is evaluating to true. Evaluating to true. So if one of these multiple conditions is evaluating to true, then it will evaluate to actually that condition, not the condition will I think I made a mistake here. I should have said that if one of the multiple conditions is evaluating to true, then its block will be executed. Yeah, that's what I meant. That we have multiple conditions to check. If one of those multiple conditions are evaluating to true, then we're going to evaluate its block. Otherwise, it's also good to say that otherwise, if all the conditions, all the conditions are false, the else block is executed. So that is what we mean here. I think I forgot to share this one. Did I share? Let me share this one. So I proceed. Should have shared that one here. And also for the now, someone who had asked whether to check whether the password is only made of letters only, you can actually check with the isAlpha function. So I'm also sharing that one right here. So from there now we can actually try them out here. So let's first see the flowchart diagram. Let's first see the flowchart diagram. So the flowchart diagram is actually telling us that in our daily life, we make decisions on daily basis. So we make decision not by checking one or two conditions, but multiple conditions. As similar to life, programming is also full of different conditions. And there we will be using the else if when we have multiple conditions. So for example, here, the program started here. It makes the first condition. If this condition is true, then we are going to evaluate that condition, and then the program will end here. Otherwise, we go to false. When the condition is evaluating false, we go and check the other condition. It's called the other alternative. If the other condition is true, we are going to evaluate its statement. If it's false, we go and check the other alternative. If all these conditions are evaluating false, we will execute the else block, okay? So we are only going to execute the block that the condition is evaluating to true. If this one is true, we evaluate its statement. If this one is true, we evaluate its statement. If this one is true, its statement. Otherwise, if all of these conditions are returning false, we evaluate the else block, okay? So this is actually how it works. I hope you're able to see that syntax. Let me increase the size so that you're able to see clearly that we have if the first condition, if this condition is true, we are going to evaluate its code. If this first condition is false, we check another condition. Else if we check this condition again, if this condition is false, we execute its code. Otherwise, if all these conditions are false, we will execute the else block. So this is actually a good example. I want to check whether a number is positive, negative, or zero. So I want to check whether a number is positive, negative, or zero. So to do this one, we have multiple conditions to check. So I would actually, I would actually press this one here, that one. Probably I would want someone to request this number from the user. So you just have to say int, then you say enter the integer digit, okay? Enter the integer digit. So I'm also sharing this one with you on the chat and try them out on your class practices. So now we are saying that, let me call this one, I should not call it A, but let's just go with A for now. So we have a variable called A that will store a number that the user will enter. So if that number is greater than 0, then the number is actually positive. Otherwise, if that number is not greater than 0, then we want to check whether if that number is less than 0, then that number is negative. Otherwise, that number is 0. So we've actually checked this condition and this condition here. So actually, we are checking for multiple conditions, okay? So let's run this one and check. If you run this one, so enter a digit. If I enter 7, I will be told that 7 is positive because it meets this condition here. So if I run again, -5, sorry. This one is a negative number because the first condition was false. So we go and check the other condition and it became true. Now let's check 0. check 0. So if I put 0, so 0 is not greater than 0. So this is false. 0 is not less than 0. This is still false. So then we are going to execute the else part, that the number is 0. So this is what we call Python else if condition. And I hope you are seeing it clearly here that it's mainly used when we are checking for multiple conditions in a program.
Hello, I have a
Yes,
question.
yes,
So since if Elif else statement
yeah.
check multiple conditions, so we can have like several Elif, like if there are
Yeah,
like 4 conditions or 5.
yes, we can have so many conditions. I can even try a good example. Let's even try a good example here. We can have, I normally work with, for example, you have a situation to build student grading system. Student grading system, where we want to say that if a student has scored 0, this should be description, sorry. If a student has scored 0, I will see my screen. So if a student has scored 0, then that student, we can actually say it's grade E. If a student has scored 40, 40, that is grade A. 50, we are going to give that student grade D. 60, we are going to give that student grade C. 70, we are going to award that student grade B. And then finally, 80, we are going to award that student grade A. So these are multiple conditions to check. And we can actually use the Python else if condition in this scenario. So to do this one, first we are going to request for the student marks as an input. We're going to say the marks, it's an integer, and then the student will enter its input marks. And now we are going to check the marks against multiple conditions in such a way that if, so this one has done it in the opposite way. So we're going to say that if the marks is equal to 40, exactly the way we've seen that one, then we can actually say that the student got grade E. Can you see that one? So we have, if this marks is equivalent to 40, then the student has scored grade E. Alternatively, if this marks is not 40, you're now checking if the marks is 50, the student has scored grade D. If that is not the case, we are going to check whether it's 60, then the student has scored grade C, and then you can proceed to B. So else if the student has scored B 70, I have seen that one. If the student has scored 70, then that is grade B. If the student has scored 80, then that is grade A. Else, it means that probably you never did an exam, so you're going to award you F. You're going to award you F. You're going to award you F because maybe you never did the exam. So it's actually how we can work with the Python else if condition. And now clearly you're able to see that we are able to check for multiple conditions in Python in using the else if condition. So to run this one, let's just confirm. So if I run this one, let's say I've scored 50. If I press enter, then the program will say that you got grade D because you've scored 50 here. Let's try one more. What if I scored 80? The program suggests that I scored A. I think I saw a very nice question from, let me just see. It's a question from Kelfas. Yes, can we have a range? That's a good question because you can even see that this program is not right. What if I scored 37? What if I scored, or let me say I scored 57? If I scored 57, the program will tell me that I have scored grade F, which is not the case. So these are what we call algorithms. As much as you're writing programs, you need to check on algorithms and check on the step-by-step procedure that you follow. Is it the right procedure? Okay, is it the right procedure that you're following? So to make this one right, just like Kelfas have observed, we have to modify our algorithm. Okay, we have to modify our algorithm. So let's modify our algorithm again, so that now we make this code more efficient. So we can actually say that for someone to score grade E, then your mark should be in a range between 0 all the way to 40. I think that is what Elfaz mentioned. So for someone to have grade D, then your mark should be in a range between 41 all the way to 50. 41 all the way to 50. Similarly, for you to have grade C, then your mark should be in a range between 51 all the way to 60. For you to score grade B, then your mark should be in a range between 61 all the way to 70. And then finally, for you to have a straight A, let's even modify it further. We say that your mark should be in a range between 71, because we don't have A minus, so you can just say 71 all the way to 100, okay? All the way to 100. So for someone to score an F, then your grade should be less than 0. Maybe you scored negative 20, that is an F. So now these are very nice algorithms that we can now implement. So now the question is, how do we get this range? How do we get this range? So this is where we use now the logical operations, especially when we are in a scenario to deal with a complex decision to make. So this is why we use now the logical operation. So let's remind ourselves about the logical operation. We said that, so yeah, let's add them here. So logical operations, logical operators. And we say that we have and we say that and will only be true when both of these conditions are true. We mentioned about or, and we say that or will be true when at least one is true. At least one is true. And then finally, we mentioned about not, and we said this is actually a reverse or the opposite of a condition. So now let's clearly see how we can use this logical operation to upgrade our algorithm to check for different range. Now it's not doing the right thing, because if someone has scored marks like 84, that should be a straight A, but here our program says that it's an F. So this is not right. It's a semantic error. So to upgrade this code, I think the best way to use is to use the AND logical operation, where we are saying that for you to score grade E, the first thing is that your mark should be greater than 0 and less than 40. Your mark should be either greater than 0 or less than 40. So we can actually say that if your marks is greater or equals to 0, that is the first instance, and your marks again is less or equals to 40. And you see, so we're actually checking the range between 0 and 40. So for example, a marks like 29, 29 is greater than 0, 29 is less than 40. So at this point, 29 lies in the range grade E. So similarly, for you to score grade D, your mark should be in a range between 41 and 50. So you can actually say here that your marks should be greater or equals to 41. So this is the upper limit. And your marks should be less or equals to 50. So that is a grade C. So now similarly, we can do the same for all these other ones here. We are saying that your marks should be greater or equal to 51. And your marks should be, again, less or equal to 60. Moving further, for you to score grade B, then we had suggested that your marks should be greater or equals to 61. And again, your marks should be less or equals to 70. Yes. And then finally, for you to score a straight A, then your marks should be greater or equals to 71. And your marks should be less or equals to 100. Otherwise, if your marks is not in the bracket between 0 and 40, 41 and 50, 51, 60, 61, 70, 71, 100, then you've scored straight F. Okay? Or probably, can also say, or probably you have you have invalid marks. So you have invalid marks. So I want you to try out this one and see whether now it's now a better algorithm, just like one of us had actually realized. So try out this one sometime and see whether it's now a better algorithm to try out. So let me run it again. So if I now have 84, that is grade A. Now you see it's better because 84 is in this bracket, it is greater than 71. So it meets the first condition as true, and it is less than 100. So 84 is A. So if I run something like, let's say I've scored 63. So 63 should be grade B, because 63 is in the bracket of being greater than 61 and being less than 70. So any question up to there? Far so good. Any question up to there? Question up to there. So I hope now you're not getting any challenge. So because our time has really passed on us today, we will proceed from here tomorrow, where we are going to talk about the nested conditions. We are going to talk about logical operation in more details, and then we now introduce Python looping statements. So in our tomorrow's class, let me just be specific, we will introduce Python Python nested conditions. And then we are going to introduce Python looping statements, Python looping statements, Python looping statements. So please, if you find time, try as much as possible to do the exercises that we have here, so that now you can test your competency on Python conditional statements. So I've actually made them in level. So the level 1 is the easier ones. So you could start with level 1. If you're able to do level 1, you go to the more complex one, like level 2 now. I think I've already even done this one for you. But you can now try this one. And also you go to level 3, whereby it's the hardest one to try. So now from here, tomorrow we now introduce Python nested condition and Python loops. So I want to share this notebook with you. And then I answer your question. And then we call it a day. We meet in the evening at 7 p.m. 7:30 p.m. Sorry. So let me see. Any question? Let me see whether there's a question. So I have shared the link. I've shared the link. I don't know why you cannot access your portal, but I've shared the link for you. Yeah, so any other question? Any other question? So if you want this one, I can also share as well. Share that one as well. So I think up to there, let's just do more practices. Like we had agreed, the more you do the practice, the better you learn programming. And how do you do practices? You can do these practices by trying out these exercises that I've actually shared with you here. Okay. So with that one, and I cannot see any more questions from you. So I wish to stop this class at this point. See you again at 7:30 p.m. And now possibly tomorrow, when now we'll be introducing Python looping condition. Okay. So with that one, let's have a good day. Enjoy your day and bye-bye.